Welcome back to the channel. As you can see right now, I've got my gloves on. I'm about to go into the garage and I'm about to continue to measure parts on the engine. So yeah, follow along.
And hello everyone, welcome back to the channel. As you can see here, we're gonna get a little bit more into the teardown of the original motor for Mitsu. So as you can see here, I'm just taking out the head studs. I got my laptop, I got my notebook, I got everything I need to take copious amounts of notes and a detailed description of what it is that I find for this motor. So as you watch me do this, don't forget to like, share, comment, and subscribe. As of right now, I'm still putting out a ton of videos for Import Alliance, some other past drivers interviews that I have, and of course the saga with Mitsu, in addition to Allison Rose and all the things going on with her. So as you can see here, I'm struggling with a couple of these studs. For some reason these studs were torqued in there. When you're actually installing head studs into a block, you're actually not supposed to torque them. It's supposed to be finger tight, and if anything, maybe slightly snug. You can never go wrong with following manufacturer's guidelines for that. So I'm going to slow it down here for a minute. You guys are going to see me use a razor blade scraper. And right now what I'm doing is I'm prepping the block surface and getting rid of any gasket material. And you see I've got the minimum and maximum feeler gauges for measuring flatness of the deck. So you see here, I'm looking at my laptop taking comparison notes, and I'm going to measure the block here in several spots. And what I've noticed, as you can see, as I'm sliding the feeler gauges in and out from underneath this machinist flat edge, I'm noticing that there are some low spots between cylinders 2 and 3 for some reason. I'm not entirely sure. I don't know if you remember this, but in the initial video of me taking off the cylinder head, one of the head studs, actually the bolt that was on the head stud actually came out as one piece. So that was actually rounds between cylinders 2 and 3, if I'm not mistaken. So you know, just really ever so slight minor warpage, and honestly it was a really snug value for the maximum I guess distance, I should say, between the deck height and the machinist edge. It was really snug using that 0.10 millimeter feeler gauge. So I'm not really worried about it. It'll machine flat. So now we're going to use our Starret dial bore indicator. As you can see, I'm using it to find the roundness of the bore. You have to measure in 3 spots. You'll see in my notes later on. You're supposed to measure top, middle, and bottom, and in 2 directions to measure for roundness. And you actually see here, I actually have the dial bore gauge oriented in a different direction. And notice how I carefully set that down in there into a hole for the block, so I don't damage it. Now, what I'm doing here is taking some compressed air and I'm blowing out all the crud for the main griddle. I'm going to measure the journals now with the same dial bore indicator. Good news is the block cylinders, they measured round, so it'll just get a line hone and a torque plane hone, so I'm not really worried about that. And the reason why I'm blowing these holes out is because you don't want any crud that will prevent achieving proper tightness of the fasteners from the griddle. So, and I also took out the bearings. I'm not worried about bearing clearance because that will be taken care of after I get this line honed, and it'll be matched to the appropriate rod bearing size and crank journal size for that matter. So in the procedure manual, you're supposed to tighten this down to a specified torque value, and then you're supposed to continue to tighten said bolt to 90 degrees. And you can see that I'm doing that here with my 1/2-inch ratchet and my socket. So see if we can actually get a close up here of that line. So on one of the corners of the facets of the bolt, you mark that on the outside of your socket and just approximate 90 degrees. You can actually get a dial degree indicator, but 90 degrees is not hard to really kind of figure out. So now I'm taking a clean rag, wiping off any oil residue from the crankshaft. You can see in that little black canister to the right side of your screen is some brake cleaner in there. So I lightly spray the rag with brake cleaner, and then I wipe off all the measuring surfaces. And we're just doing the same thing. We're just going to measure for roundness, make sure everything is copacetic, everything is good to go. Using, I have a Mitsu brand micrometer that I really love. Fun fact, I actually really like mechanical measuring devices, so you see me jamming out to some music here. But yeah, so notice you're going to use the ratchet end of your micrometer to apply consistent torque to that micrometer to get an accurate reading. You never want to over tighten it. You'll get a false reading every single time. And you see I'm checking that value 3 or 4 times, just ensuring that I got everything squared away. So if you look closely, you actually see the wear on the piston skirt. And if you look at my notes later, you'll see that is actually noted in the roundness of the board. Like I said, just a lot more measuring and just getting everything squared away. So this is a fairly quick video. This is just measuring the bottom end of everything. So as always, like, share, comment, and subscribe. Be sure to stay tuned to next week, because next week's video will actually show what actually damaged the cylinder head and the piston. So see you guys in the next one. Make sure you guys stay tuned, and I'll see you guys next week. Bye guys, have a good one.